Welcome to part 6 of the Bullshit Free Dubstep Glitch Hop Power course. My name's Tom Cosm. We're going to be working today on bassline number 5. So I'm just going to insert that MIDI track command Shift D, and we'll rename it to bass 5. And the concept I want to introduce here is a little bit different than what we've been working with on these last 4 basslines. We're going to be talking about FM synthesis. So we were working with subtractive synthesis, which is when you create a sound, a busy sound, and then you take things away. You subtract away from it using various tools to shape the sound that you like. We're going to be talking about FM synthesis now. So FM meaning frequency modulated synthesis. It's quite an interesting form of synthesis. Can be quite difficult to get your head around. It's not that hard to explain, but actually learning how to use it can be a bit daunting sometimes, because a lot of the parameters that you can change have quite a drastically different effect on the sound than what you might be used to, especially if you're used to subtractive synthesis. So I'm going to go ahead and explain it the best I can today, and we'll see if we can get a cool sound coming out of it. So I've created this MIDI track, I've got it bassline number 5, and just like before, I'm going to insert an operator, as usual. You notice I'm using operator a lot, that's because I like it a lot. So we've been working with this algorithm over here. I click down on the bottom right hand corner, this is where you can select your algorithms. These algorithms define how these 4 oscillators, or operators if you like, operate. So you can see we've got various different combinations. This particular one, what we've been using, you can see we've got 1, 2, 3, 4, and they're all coming out. So they're all playing their own individual sound. They're oscillating their own particular sound, and then they're coming out and getting mixed together, and then we can manipulate them with the filters and all that kind of thing. But we've got different ways. Okay, so let's go right over to the left here. This is the kind of the FM daddy of them. This one chains them all up in different ways. So what's actually happening here is you can see we've got yellow, green, blue, and orange. The yellow one, this is the only one that's going to be playing sound. The yellow one is the only one that's playing sound. That's at the bottom of the chain. That's where the sound comes out. This one, however, is going to change this one, and this one is going to change this one, and this one will change this one. So B modulates A, C modulates B, and D modulates C. So B could be modulating A and making A, the oscillator, do something crazy, but C could be changing the way that B changes the way that A works. So it's kind of chaining them all up in an interesting way. Now, to give you a better example of this, let me just play you a note here. Hey, there's my note. Simple. Actually, let's get up I will use, where's our spectrum? Let's get the spectrum up. Okay, so there's my note. What are we playing? We're hitting at about 192 Hertz. 195. Let's go with 195. Now, remember before we were talking about the LFO section of the operator. The LFO section, the low frequency oscillator, it'll pulsate and it will send that information of the pulsations to the pitch of whatever's defined here. In this case, the pitch of A, B, C, and D. Excuse me. So I'm just going to turn the pitch off for B, C, and D. So now this LFO is going to go up and down, and it's going to raise the pitch of A. And we can see that frequency going up and down there. As I bring it faster, bring the amount up. So this is an LFO affecting the pitch, and pretty much this is what frequency modulation synthesis is all about. For example, if I bring this LFO up, I'm going to change it from low to high. So this is going really fast now. I'm going to bring it down to its lowest rate. So that's, again, moving the pitch up and down. But what happens if we start going really fast? What happens if we start going fast, so fast that the actual rate that it's moving, the rate that it's moving the pitch up and down actually starts going faster than the initial frequency that the oscillator is putting out? We start producing our own type of sound. And the amount, let's go down low. Okay, so that's to give you an example of an LFO changing the pitch. I'm just going to bring the amount down so it's not doing it anymore. If we go over to our second oscillator, our operator here, our operator B, it's pretty much doing the same thing. Now I'm just going to select fixed here. This will turn this into a fixed frequency. Okay, we'll get into why we shouldn't use a fixed frequency, well, for melodic things anyway in a minute, but I'm going to turn it onto a fixed frequency, and I'm going to bring the frequency down very low. So let's bring it down. The lowest this knob will go at the moment is 10 Hertz. So this oscillator is playing at 10 Hertz. So if I actually go over to this other algorithm, turn off all of these, and play this oscillator, It's not going to play. Oh, because the level's not up. See how I can move this around? Normal oscillator. But by turning it into this algorithm and putting this back on, this oscillator is now using its frequency to move the pitch of this one up and down. So 10 hertz, you can see we've got 10 cycles per second, and it's wobbling this up and this oscillator's sine wave up 10 times per second. If I bring it up, hear how that's really drastically changing the sound. Now, that's all good. We've also, just while we're there, we've got a multiplier here. So let's say 10 isn't low enough. We can go down to multiply it by 0.1. And we've got 1 hertz, 1 cycle per second. We can even go right down to 0.001, which is going to take a long time, so we won't work with that. And we can go up as well if we want, up to 10. That'll be just stupid, but... Okay, sorry about that. Okay, so set it back to 1. Not that it matters for what we're about to do, but okay, so that's, I'm defining the frequency at which it's going to vibrate the pitch of this up and down. But that's not too handy. It's good for percussive stuff, but it's not particularly good for what we want to do at the moment. So by taking it off fixed, this operator is going to oscillate at the same pitch as what this oscillator is. Okay, this oscillator is going to oscillate at the same pitch as this oscillator, except this oscillator is going to be oscillating the pitch of this oscillator, and this oscillator is just going to be putting out the actual sound of the oscillation vibrating. So to give you an example, now the cool thing about this coarse value, if you remember before when we were talking about harmonics, the coarse value actually goes up in harmonics. So if I just move it up with the sine, this is really neat because that means we can change the coarse value to the first harmonic, second harmonic, third harmonic, fourth harmonic. We can go up and up and up. And we know that the rate that this is going to be vibrating the pitch of this oscillator is going to be mathematically relative to what the frequency of what we're actually playing, which will create much nicer tones. So for example, let's bring the level up a wee bit. Let's bring the coarse up to the first harmonic. Going to turn it down a bit, going deaf. Go right up high. That's when we get those really harsh sounds. So just like before, we're kind of changing the rate value like we do in the LFO of the pitch, except we're doing it up the series of harmonics. Interesting stuff. And the level, of course, is the same as the amount. So this is how much vibration it's going to send it. And it's doing it so fast, it's just creating a new sound. That's all good, but as I said, we can use C to vibrate the rate of this oscillation, and then this oscillation is vibrating the pitch of this operator which is coming out. And of course, one thing Ableton have kindly given us in this operator is, usually in FM synthesis, you only really use the relationship between the operators, or the oscillators, the operators, to actually define the sound. But we can still use our subtractive synthesis tools over here. So let's create something busy. We can still use a filter on it, which is quite cool. But we won't get into that for now. Now, the other cool thing, I'm just going to bring the level down and C down. So we've only again got B modulating A. And they're both sine waves, one sine wave modulating another sine wave. But the cool thing is we can change the wave shape. So all of these ones that we were working with, the sine, the saw, and the square. Now I've got all these other little ones. These are ones that just have particular harmonics. For example, if I go saw 3, you'll notice it's given us a saw wave, but it's only given us the first 3 harmonics. We go into the 16, the only given us the first 3 harmonics. So that's going to create, and that's going to now vibrate the pitch of this sine wave in a saw wave shape with only 3 harmonics. Let's just scroll through the list. I believe if I pick one and start pushing the down key, that's noise, we don't want that. And they're giving us these little, that's a cool one there too. So just to give you an idea, now I'm just going to use a sine wave here again. Let's go up quite high. Bring the level up of this one. I'm just going to bring the levels up and try and find something nice and really in your face. Awesome, but of course we have envelopes. Okay, so we have volume envelopes on these oscillators. Before we just use them to control the volume, but now these envelopes are still controlling the levels or the volume, but these are actually, but the levels have kind of turned into how much this particular operator is going to frequency modulate the one below it. So if I was to bring the sustain and decay time short of this, we've now just got our saw wave, but we've got a bit of a punch. We've got a bit of a sound to it. And of course, we can change the attack as well. Excellent. Let's bring that up again. We can put the attack on this envelope of the C. So you can kind of hear that tone, and it's quite. Once you start getting good at this, you can kind of really pick an FM sound when you hear it in a tune. You think, oh yeah, that sounds like an FM synthesized sound. So what are we going to do with this? Right. Okay. I'm going to bring these. We're going to make a bass line. That's about my extent of explaining FM synthesis for now. Let's bring up the sustain back up. Bring the sustain back up of this one. Let's listen to our sound again. Nice and horrible. Let's bring this up. Let's bring in the fourth one just for fun. Alright, let's get rid of that spectrum. So, here's our tune. It's way too loud, isn't it? Let's bring it down. Let's put one big note in this clip. And we're working with D. Let's try and pick the right pitch this time. Probably not. Down one more. Now let's move this level here. Let's automate that. So again, as I move this, we have a corresponding line up here on the timeline. Let's double click a point, and let's just open that up. Let's try a different waveform. Let's try a saw, see how that sounds. It's kind of cool. Let's bring the coarse value up a little bit. So you can see I'm just mucking around here, changing the coarse value of this one. Remember, this one's affecting this one, this one's affecting this one. I can put this one really high. Alright, I'm going to roll with that for now. That's quite a lot of fun. And just... Okay, go back to this level. I'm just going to start the level of the second one, which is causing that really big kind of opening up sound to open up. I'm going to actually bring it forward a little bit and give it a bit of attack myself, a bit of decay myself. So... And maybe if we zoom in just for that part where it's going down and then opening up, let's make the level, let's make the coarse of just these two here. Let's make it really high. That's pretty cool. Okay, now I'm just going to whack away my pen tool. That particular part there sounds like a different note, so I'm going to add in a filter delay. Now we use this, I think, in the first one. So I'm going to use this as a spatial effect rather than an actual delay. So I'm going to turn off the middle delay chain. Remember, it's got 3, 1, 2, 3. We're going to take off the middle one. I'm going to bring this dry volume down. So this is how much of the original signal is being sent through. I'm going to bring that right down to negative infinity, so it's not playing at all. We're going to turn the sync off on each of the sides, the left and the right, so we can use milliseconds instead of fractions. Bring them really down, and let's just go 1.78 to 8. And let's bring the bandpass filters on each of these sides up, just so they're covering pretty much the whole spectrum. And the volumes are a little bit off. Let's make both of them 0, 0, 0. So each side is the same level. All good. Now what I'm going to do is I'm going to turn this off. You'll see how we've got a line now for the off and on button. And I'm going to have it on by selecting the pen tool and just selecting that part. So now we should just get a stereo effect just on the last part of the synth sound. Excellent. Now one more trick I want to show you here, just while we're on a roll, is I'm going to chuck a reverb after this. I'm going to give it quite a lot of decay times. This is going to sound quite muddy at the moment. But of course, we've got this dry wet value here, so I can have this right down, and I want it to come up just about here. So let's see. Alright, now what can we do with this? Well, let's use a new audio effect over here. This is called a gate. I'm going to drag the gate after the reverb. Just going to delete the spectrum, we don't need it. Now the gate will, you set a particular point, and if the volume goes over that point, it's going to play it. If it's underneath, it's not going to play it. So that's how it goes. So let's have a look. It's playing everything there. If I have this up here, you see how the volume is not reaching that threshold point? It's not really playing anything. But as we used the side chaining before in the first example, and I believe the second as well, potentially, side chaining meaning we can tell this gate to actually listen to another aspect of the tune and act accordingly depending on the state of it. So what we can do is we can turn on the side chain here by using this little arrow. I can go side chain, I can tell it to pick the audio from any of our other tracks. Well, we could use our drums, for example. That's actually not bad. I'm just going to turn that gate off and just automate it so it's only on after the phrase. That's pretty cool. I like that. So it's listening to the drums and it's gating it. It's letting the volume come through when the drums are playing. That's pretty neat, but that wasn't what I was going to show you. But that's another cool little accidental example that we've used. I'm going to create another track here, a MIDI track. So I went Command Shift T, and we're going to call this Bass 5 Gate. And in this Bass 5 Gate, I'm going to insert an operator, like so, and I'm going to put in. Let's just make it a one. Oh, that's way too quick. Oh, that'll do. I know it won't. 1 bar loop, so 35 to 36, insert a MIDI clip, open it up. Actually, I'm going to make this 1 beat, so it's at 1 bar. Let's make it 1 beat. 3, 2, 1. The reason I've done that is I'm just going to put in some notes here. It doesn't matter where I put them. Actually, it does. I'm making them 16th notes. Okay, I'm going to drag my swing on top of it. So what I've actually done here is I've created a kind of a dummy clip. I don't actually want this audio to play, but I want that gate to actually sidechain from it. So I can actually program a rhythm into here and know that the gate is going to be turning off and on and letting that reverb through, depending on what the actual rhythm is here. Now, one thing we need to make sure we do is if we look over here in this section, this is where our inputs and outputs are. At the moment, the output of this Bass 5 gate is going to the master. So it's going out of here and it's going into the master channel. This is where everything finally gets fed. Everything has to go to the master if it wants to get played audibly. But we can go into the master and we can go sends only. which means it'll only send to the sends, but because the sends are sent to negative infinity, these are our send return tracks here. Because these are sent to negative infinity, it's not actually playing anything. It can't be sending to the master. It's saying we'll send it to these two, but these two volumes are turned down. This is where send A and send B are. This is where the returns are. We can send stuff to send A, we can send stuff to send B, and it will get sent to these two tracks here. But we're not doing that, so it's not going to play. However, the gate can still pick up exactly what's happening. So if I go audio from bass 5 gate and play this again, great. So we can actually go in here. Let's make these a lot shorter. See what happens. Now I can consolidate this clip even. And let's add in a few little quick rolls. Let's make that one a bit longer and make this one a bit faster. Just to see what happens. Cool, and now we can loop that and drag it out. Let's have a listen. So that's a cool little trick there. Just before we move on, I'm just going to fix this up a little bit. At the end of the, once we've done the bass lines, we're going to go through and really get into using all of these tools into a cool track. I'm just kind of putting them in place at the moment. I'm just going to change this because I don't like it. That should do. Awesome. So that was, what was that? Oh, last thing I'm going to do, let's group these together because they're the same thing, bass 5. Let's group those together and call that group bass 5. And that's just because if we want to actually change something within that track, we can put effects and stuff over the top of this actual group. Not that it matters because this is a dummy track, but it's just good common courtesy to do it. Okay, so that was tutorial number 6, bass number 5. Yeah, tomcosm.com. Cheers.